Good morning, my dear JEE warriors. Welcome to the time where we take revenge on NTA by solving the new trending PYQs with the concept in this detailed one shot. Starting off with the highest weightage topics. As you saw, yesterday I did the trend analysis, which is what we can expect. We never know, NTA can always throw surprises. But based on the trend analysis, we are taking up the chapters of highest priority, and that is nothing less than ray optics. Ray optics, the most important chapter, which came up in January 2025. So let's begin with the questions, guys, with your captain Shreyas. Nice to see all the warrior pandus. Vanakkam, vanakkam, namaskara, Endariki namaskaram. Good morning. Good morning. Yes, your captain Shreyas is here. Hi, Gauri, single spec, Pausan, Lakshita, Nikhil, Ayanshu, Sri, Bala, Shivra, Navnita. Good morning, Nikhil. Yes, let's go. Pranad, let's go. Correct. Good morning, gaming. Afzal, Aditya, Ram. Welcome, Lakshmi. Welcome, Javlita. Welcome. I do remember you, definitely. Let's begin with the class and starting off with the first concept, which is going to be spherical mirrors. Then we'll go to mirrors formula, refraction, lenses, combination, power, total internal reflection, prism. All these things we'll be doing in the class today. Okay. Just to do a quick recap of reflection can occur at plane surfaces or curved surfaces. Whenever the refraction occurs at a plane surface, we know that the light which is incident gets reflected such that the angle of incidence equals the angle of reflection, and the light is also deviated given by 180 minus 2 times the angle of incidence. And of course, the angle of incidence is equal to angle of reflection. So this is true when you have a plane surface to refract, but we know the surfaces need not be always plane. Even if it is curved, reflection can still occur at every single point on that particular surface. Reflection can still occur at every single point on that surface, and every point can be assumed like a small part of a plane mirror, and that is how you can find out how the reflection is happening on a curved surface. We specifically have the formulas for spherical mirrors where the curvature is a sphere, not anything else. So things like over here, this is a concave mirror. The rays which are parallel meet at the focus at this particular point. In this case, this is a convex mirror. You will see the rays which are parallel, they will diverge and they appear to originate from the focal point. They won't actually physically meet. Well, in this case, you will see that the focal length will be negative, whereas in this case, you will see that the focal length is positive. This is a concave mirror and this is a convex mirror. The sign convention always begins with the by the look of the incident ray, how the rays are coming from the object. So if the rays are going like this, if the rays are falling like this, always take the pole, the center of the mirror as the origin. If that is the origin, anything in the top is positive, anything below is negative. The direction in which the incident rays are going, that points towards the positive side of our convention. So automatically, if incident rays are going like this, towards the right side, it is positive, left side will be negative. If the rays were coming from this side, then this side would have been positive and that side would have been negative. That is how the sign convention works. Like you can see over here, the object is here. Okay, if the rays were coming from here like this side, then obviously if it was coming this way, this side will be positive, that side will be negative. Automatically things will change. But usually you will see most of the times right side is positive, left side is negative. That's how we usually end up placing the mirrors or the lenses. Okay, direction always the direction of incident ray points towards the positive side, and always the pole is taken as the origin. Of course, you should also remember that the center of curvature is here, and the distance from the pole to the center of curvature being the radius of curvature, that is always double of the focal length. So focal point is the midpoint of center and the pole. So if you take focal length 2 times, you get the radius. Focal length 2 times, you get the radius. Focal length 2 times, you get the radius of curvature. Everybody fine till this point? Yeah. Now, do all the rays converge on the focus? Well, only the paraxial rays converge on the focus, and we take small spherical mirrors or the rays which are close to the principal axis. Technically, if you find out, the rays which are farther apart will not be exactly converging, which causes that blurriness, often called as the spherical aberration. So, the manner in which you make sure all the rays converge at the same point is, instead of using a spherical surface, you use a parabolical surface. And the parabola has the property that no matter where the rays are, they will exactly coincide at the focal point. But we do not have parabolic mirrors in our syllabus, but just letting you know how it is being taken care of. So the formula for locating the image is 1 by V positive with 1 by U is 1 by the focal length. 1 by U plus 1 by V is the focal length. Next important thing is the magnification. So this formula to everybody must definitely know. Okay, this formula 1 by V mirror formula. This one, the radius and the focal length relationship. This one obviously is your mirror formula, mirror formula, mirror formula. Then you also have the magnification formula, which is negative V by U. Remember one thing, if magnification is positive, it means the image is going to be erect. If the magnification is negative, then the image is going to be inverted, inverted. Similarly, if the magnitude of the magnification is equal to 1, then it is of the same size. But if it is more than 1, then it is enlarged. It is enlarged. And if it is less than 1, then it is being smaller. It is diminished. It is how high the image is upon how high the object is. It is basically the ratio of them. Yes, it is basically the ratio of them. Very good. Another important formula which I think you must be aware of is what is the image velocity upon the object velocity, which is having the same formula as the magnification longitudinally. That is along the principal axis, along the principal axis, along the principal axis, which is the length of the image, length of the image upon length of the object, length of the image upon the length of the object. Yep. So this is having a formula minus of V square by U square. Again, a very important formula which every student should remember. Magnification longitudinally. This was the perpendicular magnification, transverse magnification, which is usually the case. But if a specific question along the length, if there is an object, it might get stretched along the length of the principal axis, then you will use minus V square by U square. Last formula is the power of a mirror. Many people forget this. This is used in the silvering of lenses. That formula is minus 1 by F. Yes, the formula is minus 1 by F. Keep this in mind. And if the power is positive, it is a converging mirror. If the power is negative, it is a diverging mirror. So power will be negative, obviously, for a convex mirror because it is diverging in nature. Because it is diverging in nature. In fact, you can see for a convex mirror, the focal length is positive. So if the focal length is positive, minus into positive will make it negative. So the power of a convex mirror will be negative in nature. Everybody clear? Okay. So Nitesh, around 2 hours easily. Yeah, I'm not sure. It will be around 2 hours, maximum 3 hours, but it won't be too long. It won't be too short. let's start with some questions on your screen. But guys, I want everybody to participate as quickly as possible so that we solve maximum questions. You're not very late, we just started. Okay, great. So what about this? What about this, guys? A concave mirror of certain focal length is in air and it is dipped in a liquid of refractive index. The focal length in that liquid will be. How will the refractive index of the liquid affect the focal length of any kind of mirror for that matter? Whether it is dipped in a liquid, whether it is in air, the answer is always the focal point will remain the same. In fact, that focal length is just dependent on the radius of curvature. It is independent. It is independent of this. It is just independent of this. Reflection will still occur the exact same way. So it is a B option exactly. It was asked in January 2025. It was like a very nice question which can confuse some students if you are not conceptually strong. If the distance between the object and the 2 times magnified virtual image produced by a curved mirror is 15, then the focal length is. By the way, I also need to remind you that in this particular thing, how do you know whether it is virtual or real? See, if the image is behind the mirror, if the image is behind the mirror, meaning the sign of image is positive, then it will be virtual. If it is in front of the mirror, then it will be real. So usually you will see things like behind. It is, if the image is formed behind the mirror, then it is virtual, and if it is in front of the mirror, then obviously it is going to be a real image. So that you will get to know from the sign of the image distance, which is over here. Okay, so in this particular question, the 2 times magnified virtual image by a mirror is 15 centimeters. So let's just assume that there is some kind of a mirror over here, and I do not know what kind of mirror it is. I just know that I have placed an object over here. I have placed an object over here. Let's say the distance is x, and let's say the image is formed over here. It is virtual, so it is behind. So this is, let's say, y. So this is where the image is. This is obviously the virtual side because it is behind the mirror. I don't know what kind of mirror this is. I know you guys are wondering why I have drawn a straight rectangle thing. I do not know whether it is concave or convex, so it is not given to me. So Chumma, it's an unknown mirror. It's an unknown mirror. So now the total distance between them obviously is given to be 15 centimeters. So I'll just mark that as well. The question is the find the focal length. Now, as per the given information over here, my dear students, 2 times magnified image. So magnification is basically 2. Magnification is basically 2. Everybody with me? Yes, the magnification is basically 2. So what do you do now? The magnification formula we know is nothing but minus V by U. Yep. So magnification is 2. It is nothing but minus V by U. V is image distance and U is nothing but your object distance. V is image distance, U is nothing but your object distance. So what is V over here? That is nothing but Y. And what is object distance over here? That is nothing but 15 minus X, but with a negative sign. But with a negative sign. Everybody with me? Understood why there's negative sign is there? Because this will be the negative side, this will be the positive side as per the sign convention. Reason being, the rays will come like this from the object. So the rays are going to this side. So this side is positive, this side is negative. So object is on the negative side. So minus sign over here. So now just rearrange this. So sorry, why did I put 15 minus x? My bad. This was minus x, my bad. So just rearrange this and also put negative as positive. So this will be y by x. Now you can also write x as 15 minus y. You can also write x as 15 minus y. So this will become 30 minus 2y is equal to y. So 30 is equal to 3y. This means y is equal to 10 centimeters. So we got the image distance as 10 centimeters. From this, immediately we'll get the value of x. So x will be 15 minus 10, which is 5 centimeters. So therefore, x is 5 centimeters. So the last thing is to find out the focal length. So use 1 by v plus 1 by u is equal to 1 by f. So what is the image distance? Image distance is 10. What is the object distance? It is minus 5 because x is 5. So with the sign convention, it is minus 5. This is basically 1 by f. So solving it further over here. So the LCM is nothing but 10. So 1 minus 2 is equal to 1 by f. So this is minus 1 by 10 is 1 by f. So f is nothing but minus 10 centimeters. So minus 10 centimeters is there somewhere? It's there as option labeled A. Correct. Awesome. Why did you draw the diagram? This is just for our clarity so that we don't make silly mistakes. In the rough work, please draw a diagram. Don't be a hero saying that, oh, I can mentally think and I will do it. There is a good chance you might make some stupid, silly mistake either in the signs or in the plus minus here, addition, subtraction, something might go wrong. Because this is negative 100%, it is a concave mirror and we did not know this till the end of the problem until we solved it. Is that okay? I'm so glad, Radhika, this is your first class, and I'm pretty sure it is going to be very super duper helpful for you. Okay, stay till the end. So let's go with the next question. Yep, let's go with the next question coming up on your screen. Okay, a convex mirror of certain radius forms an image which is half the size of the object. The object distance is. Imagine a convex mirror. Okay, let's take a convex mirror. That is a convex mirror like this. Okay, let's show the principal axis over here like this. It forms, the radius of curvature is also given. Okay, so it forms an image which is half the size of the object. We know always convex mirrors form virtual, erect and diminished images. So if this is the object, if this is the image, so this image is virtual, it is diminished, and it is erect. This is how convex mirrors behave. Everybody remember this? Yes, correct. Very good. So now what is the next step? We know that the radius of curvature is given and it will be having the focal lengths on this side only, both of them. So if the radius of curvature is plus 30, focal length, which is r by 2, will be 30 by 2. So it will be 15 centimeters. It will be obviously positive in value because it is on the right side. Okay, that is also done. Now, since image is half of the size, so magnification must be positive because it's a convex mirror. So it has to have an erect image. So magnification is positive because of its erect nature. So the magnification is plus half, and that plus half is nothing but your image distance by your object distance. It's nothing but your image distance by your object distance. So neither of the image distance nor of the object distance is given to you. So I'll just mention this as M. Is somehow magnification related to the focal length and the object distance? I think it is. I think it is. What we can do, again, we can say that usually our magnification is minus V by U, and 1 by V plus 1 by U is equal to 1 by F. I want to get rid of V. So what I will do from here, 1 by V is equal to 1 by F minus 1 by U. So therefore, 1 by V is equal to Fu into U minus F. Therefore, V is equal to Fu divided by U minus F divided by U minus F. Now what I will do, use this magnification. Now magnification is minus V by U. So it will be minus of, instead of V, put this as Fu by U minus F. U gets cancelled, take the negative, swallow it inside. So it will become F divided by F minus U is the magnification. So I think this formula is better to be used over here. So instead of M, I can put F divided by F minus U. So that will help me solve the question easily. So that will be half. So focal length is nothing but how much? 15. So half is equal to 15 by 15 minus U. Cross multiply. So 15 minus U is 15 to the 30. So take it over here. So 15 minus 30 is equal to u. So therefore u is equal to minus 15 centimeters. Minus 15 centimeters should be the answer for the object distance. Is that absolutely clear, everyone? You missed the starting part where I just quickly revised the theory of the curved mirrors. Yeah, but other than that, I think it's fine. Cool. No, it's not minus 45. I don't know why some of you said minus 45. It is minus minus 15. Yeah, be careful. Do you want to, should I solve together? See, if you know decently well, then I think you can solve together. But if you're little bit or below average or you're not so confident, then I would say watch the lecture properly, scribble, don't have to solve completely. Just see what Shreyas Sir is writing. Okay, just write it down briefly, not all the steps, just to keep a track of things. Later on, solve it completely just as practice, at least the questions part. Okay, next. A concave mirror is producing an image of an object such that the distance between the object and image is 20. The magnification of the image is -3. The magnitude of the radius of the curvature. Similar model again you can see was asked previously. So let's see how do we solve this particular question. So we have a concave mirror. Okay, and the magnification produced is given to be -3. Magnification is -3. Magnification formula is minus V by U, which is nothing but -3. So V by U is basically 3. So V by U is basically 3. But the distance between the object and image is also given to be 20. Distance between object and image is given to be 20. Now, if the magnification is negative, well, inverted image is being formed by concave mirror. If the image is real, so maybe the object will be over here. Object will be over here. Maybe the image will be somewhere over here. That's how roughly the diagram looks like. Yeah, if you remember correctly. Now, this distance is given to me. This distance is how much? This is 20 centimeters. Let's assume the object distance to be x. Let's assume the object distance to be x. Okay, distance between object and image is given. Between image and object is also image and object is given. Object and the mirror, I have assumed it as x. So what over here is v? Just think about it, because this is negative side, this is the positive side. Always diagrams are very crucial. Object distance will be -x, so u will be -x for sure. What will be image distance? Well, if you notice carefully, you will realize this entire distance is 20 and x together. So 20 plus x, but with a negative sign, of course. So this will be minus 20 plus x. This is equal to 3. Minus minus just cancelled. So 20 plus x is nothing but 3x. So 20 is equal to 3x minus x, which is 2x. Therefore, x is nothing but, what is it? 10 centimeters. So the object is placed 10 centimeters. Yes, yes, that's it. Now, what is next? I will use the mirror formula. 1 by V, 1 by U is 1 by F. What is the image distance? 20 plus x with a negative sign. So 20 plus x, what is x? 10. Okay. What is object distance? It is just x but with a negative sign. So minus 10 is equal to 1 by F, of course. Yep. Very good. So what is this going to be? Come on, guys. This is minus 30. This is minus 10. So take the minuses on the other side. So 1 by 30 plus 1 by 10 is equal to 1 by f with a negative sign. So the LCM is going to be 30. So it will be 1 plus 3 is equal to minus 1 by f. So it will be 4 by 30, which is 2 by 15 is 1 by f. So therefore, f is equal to 15 by 2 centimeters. But we have to find the radius, because that's what the question is. Radius is 2 times of f. So it will be 2 times of 15 by 2. So 2 cancels and you will get it as 15 centimeters. I think B option is the correct answer. Very nice. Amazing. Got it? Perfect. Yeah. Focus formula. Yeah, we will use it towards the end. R is equal to 2f. Not now. Before that, we have to use the mirror formula to find the focus where it is, and then we will use the focus is equal to R is 2f. Okay, Nikhil? Fine. I hope you guys are getting a hang of how to solve these questions. Okay? Great. Loving the session, guys. I hope you have smashed the like button. Yeah. And I hope you have called your friends also to the session, to the number one JEE English channel in the country. Because Captain Shreyas Sir is here. And whenever Captain Shreyas Sir is taking the classes and the entire team is over here, we have been predicting the CBSE paper very well. We predicted the last year's JEE Mains papers. We predicted this year's JEE Mains was going to be tough much before anybody else. And this time, again, I'm telling you, April is going to be extremely competitive. So be prepared. And that's why we are going to put the preparation at a higher notch, not doing those easy laddu questions, because they are not going to give you any seat. They will not even give you 90 percentile. So you have to level up your game. There is no other way. JEE has become serious business, boys. You need to be a Sigma. You can't be a clown anymore. And I'm pretty sure every student over here is going to be a proper Sigma over here. Okay. So thank you so much for showing all your love, guys. Next one on your screen. There is a driver sitting inside a parked car is watching vehicles approaching from behind with the help of his side view mirror, which is a convex mirror. Radius is given. Another car approaches him from behind with a uniform speed. When the car is okay, parked car, that means the mirror is at rest. Okay, that's very important. The mirror is going to be at rest. That's very important. Okay, parked car. So this is the rear view mirror. So this is the parked car's mirror, convex mirror. This is our principal axis. Definitely. Thank you, MG the Vlogger. Thank you, Ananya, Aditya, Jarvis. Thank you, Nikhil. Yep. Let's move. So now the radius of curvature is meters. So the radius of curvature is 2 meters. R is nothing but 2 times of F, that is 2 meters. So focal length is 1 meter, which is 100 centimeter. Yep. And it is going to be positive because it is a convex mirror. So focal length is on that side. So the car is going to approach with 90 speed and the car is at a distance of 24 meters from him. So this is the object. This is that particular object moving with 90 speed and the distance is how much? 24 meters. So I think let's keep everything in meters. I don't think we will need in centimeters over here. So let's keep everything into meters only. Okay. And because of that, what will happen? That image of that particular car, the image of that particular car will also appear to move. So the question is the magnitude of the acceleration of the image of the car in the side view mirror is. The magnitude of the acceleration. Crazy, guys. This is a very good question. The magnitude of the acceleration of that particular car is being asked. So let's see how do we solve this. Maybe I will need 2 slides or something. Okay, so first of all, I think let's locate where the image is going to be formed. So let's use 1 by V plus 1 by U is equal to 1 by F formula. The image distance I do not know. Object distance is negative 24. Focal length is basically 1, so positive 1. So 1 by V is equal to 1 minus will become plus. So 1 by 24. So it will become just 25 by 24 is 1 by V. So therefore, V will be 24 by 25 meters. Just check this out. V will be 24 by 25 meters. Everybody with me till this point? Great. Now, remember, just some time back, I had mentioned something about longitudinal magnifications and image velocity by object velocity. If you remember correctly, I had given these formulas just some time back, and I told you this is also very necessary. Although in NCERT it is not directly given. Image speed by object speed is minus v square by u square. Okay. So what will be the use of this? What will be the use of this? Let's come back to this question. Where is it? So if I use the image velocity by object velocity formula, which is negative v square by u square. So v is nothing but 24 by 25 and object distance is just nothing but 24. So squaring it, 24 will cancel. So I'll get minus 1 by 25 the square, which is minus 1 by 625. That is image speed by object speed. Now, is the object speed given? Yes, it is 90 kilometers per hour. Now, 90 kilometers per hour, 90 kilometers per hour converted into meters per second, how much will it be? Yeah, first convert this. Where is this? 90 kilometers per hour multiplied by 5 by 18, guys. It goes 5 times. So this will be 25 meters per second, of course. So object velocity over here technically is 25 meters per second. This 25 and 625 will cancel. So the image velocity will be minus 1 by 25 meters per second. Everything is in meters per second. But the question is not about finding the image velocity. Mind it. Yeah, a lot of people just might leave the answer over here. No, the question is about finding the acceleration. Finding the acceleration. Now, how do you exactly find the acceleration of this? How do you basically find the acceleration of this particular quantity? I'll tell you what. Go to this equation. Let me go to this particular equation, which is nothing but image velocity by object velocity is negative v square by u square. Let's just cross multiply. So therefore, vi into u square will be minus v square into vu. You know what is the advantage now? Everything has velocity over here. How about differentiating it? Yep. Just take the derivative with respect to time, vi into u square, and this is negative derivative with respect to time, v square into vu. What is the derivative of this? Product rule, image velocity into derivative of u square with respect to t plus u square into derivative of image velocity with respect to time is equal to negative v square is there as it is derivative of object velocity with respect to time and plus actually object velocity is a constant, so I don't even have to break my head. Just object velocity will come outside. It is approaching with a uniform speed. So VO is a constant. So I can just take it outside. So that was just a constant into derivative of V square with respect to time. Is this equation clear? I just use the magnification of longitudinal formula, which is image velocity by object velocity, which is negative V square by U square, cross multiplied and differentiated both sides. Amazing. Now, no need of Newton equations. Observe this now. What is this? Image velocity du square by dt. So that will be two times of use chain rule, into du by dt plus u square. Derivative of the image velocity is the acceleration of the image is equal to minus v naught. V square's derivative will be 2 times v into rate of change of the image distance. Now observe everything carefully, guys. Things are going to be very interesting now. Image velocity multiplied by 2u multiplied by rate of change of object distance is object velocity. Du by dt is object velocity. U square is there multiplied by image acceleration minus Vo multiplied by 2v. dv by dt is nothing but rate of change of image distance, which is nothing but image velocity, So now in this, everything is known except for AI. Yeah, everything is known to you guys. That is the crazy part. Everything is known to you except for AI. Yeah, everything is known. What is the image velocity? We just figured it out. It is minus 1 by 25. So minus 1 by 25. 2 into u, object distance. Object distance was minus 24, if I'm not wrong, minus 24 into object velocity. Object velocity was 25 meters per second. So that is the first term. Plus u square, object distance. Object distance was minus something we wrote, right? 24. So it will be 24 square, object distance square, into acceleration of the image, which I do not know, into, is equal to minus VO, object velocity, 25, 2 into V, image distance. Image distance, we calculated it 24 by 25. So put 24 by 25 into image velocity, which was minus 1 by 25, which was minus 1 by 25. Just have to solve this. You will get the acceleration of that image. Understood, guys? Understood, guys? Yes, such an amazing, amazing question. And the answer that you get totally is 8. If you get the total answer as 8, so the acceleration will be 8 by 100, which is 2 by 25. I think you should get this as 2 by 25 meters per second square. Just check this out. After solving this, you will get it. So therefore, 100 times of that acceleration will be 100 multiplied by 2 by 25, which is nothing but going to give you the answer as 8. Very nice question. Loved it, Sukhuti. Isn't it amazing? Because usually you will never find questions on acceleration. Very, very rare. Unless you have solved the advanced material from this book. Yeah, you will find questions of, yeah, acceleration of images. Yeah, the JEE Advanced Rank Accelerator book has all kinds of questions. You think of a question, it is there in this book. Okay, so you can check out the link which is there in the description box below for your JEE Advanced preparation. So let's go to the next part, which is refractive index, guys. Now, let's quickly revise all the concepts of refractive indices. So first of all, sine of I and angle of incidence upon sine of angle of refraction is equal to the refractive index of the second medium upon refractive index of the first medium, which is also called as the relative refractive index of 2 with respect to 1, which is also the speed of light in the first medium upon speed of light in the second medium. Notice how this is 2, 1, this is 1, 2. That's the catch. Be careful. This speed of light is frequency into wavelength. But remember, the frequency is always going to be the same. Even if I put it, it will get cancelled. So lambda 1 and this is lambda 2 over here. This is the most generic equation which you can ever make from your refraction formulas. So please remember this, guys. Very, very important formula. Snell's law combined with everything. Yeah, sin I by sin R is refractive index absolute of the other medium, the refracted medium upon the incident medium, which is speed of light in the first medium upon the second medium, and which is also lambda 1 by lambda 2. In this case, what I'm saying is the medium 1 is over here. This is medium 2, and our light is going like this, and it is going here. Yeah. So obviously, this is incident angle. This is refracted angle. The angle of deviation is modulus of I minus R. Again, something which you should be noting. Yeah, it is the modulus of the angle of incidence minus the angle of refraction. It is not 180 minus 2i. 180 minus 2i is for plane mirrors. Don't get confused. While saying you will call this as refractive index of 2 with respect to 1, and needless to say that when you have 1 mu 2, it is obviously reciprocal of 2 mu 1. 2 mu 1. If you want to swap it, you just take reciprocals. That's how you get the exact opposite relative refractive index. Yeah, keep this in mind. Also, uh, over here, yeah, I think most of the things are done. Yes, if there are multiple layers, and our ray is, say, for example, going like this, then getting refracted, then maybe again getting refracted over here, and maybe getting refracted over here. Every medium 1, 2, 3, 4, etc., you will notice that sine of that particular angle into refractive index will be sine of that particular angle in that medium into refractive index of that medium. That product will be basically a constant. Even if you have multiple layers, this will always work. Keep this in mind. Okay, so I think with this we'll start some questions on the refractive index of plane surfaces. A hemispherical vessel, read it carefully. I know you might get scared looking at the bowl with the water filled and some curved surface, but that is exactly what happened with many students. Students thought this is one of the scariest question ever, but actually it was not. So let's understand this question. There is a hemispherical vessel. It is completely filled with a liquid of refractive index mu, okay, till the brim. Hemisphere, so this is radius, this is the radius, this is the radius, okay, it's half of a sphere. There is a small coin at the lowest point of the vessel, the minimum value of the index, so that a person can see it from outside. The minimum value of the refractive index of the liquid, so that a person can see the coin from point E. Oh, the person should be able to see from point E. I'll tell you what we should do. mg the logger v1 by v2 is the velocity where you are saying in the previous question. This one, vi by vo, image velocity by object velocity. O for object, I for image. This is the formula. Negative image distance square by object's distance square. That's the formula. That's the symbol I'll use. I'll not use v1, v2 because it will be very confusing then. Okay. So now I'll tell you what. If I can see you, can you see me? Or not right now. I can't see you now because obviously you're on the other side of the computer. But in optics wise, if I'm holding a lens and if I'm able to see something, that something should be also able to see me. Like for example, if slyly you are seeing somebody from a mirror, there is a mirror somewhere, and if you are able to see the person, even that person should be able to see you. Agree or disagree? Yes or no? Have you ever tried this? Suddenly you are seeing somebody through the reflection of a watch or some mirror placed somewhere or some shiny surface, and you're like, okay, I'm slowly, Pandu is checking out Champa through the mirror. Pandu thinks Champa can't see him, but actually Champa can also see Pandu, right? How is it not possible? It is reversibility principle of light. Yeah. So same thing. If E can see O, O can see E, E can see O, O can see E. Okay, great. So what's the next? So there are different possibilities. Like for example, the ray of light can go like this and go like that, so that it enters the eyes of E. This is one possibility. Second possibility, I can say, okay, like this, the ray goes like that and then enters the eyes of E. Okay, that is also a possibility. Yes, sir, perfect. I can also take another ray, maybe starting from here, and this is the last possibility. I mean, slowly I'm changing the angle of incidence, and finally it enters the eyes of E. So this is also a possibility. But in which of these scenarios, light pink, dark pink, or green, will the refractive index be minimum? In which of the following do you think you will get minimum refractive index, minimum value of the refractive index? Is it the green, dark pink, or light pink? Quickly think about it. Quickly think about it and let me know the answer in the chat box right now. If you notice, in the green one, the light is refracting, but with a big angle. Here it is smaller. Here it is refracting very fast. So that means the refractive index will be more here. So definitely the light pink has higher refractive index, whereas the green one out of all of them has the least refractive index. So the question is, no, no, no. Many people said light pink. No, guys, it is the green one. The green one. Because if light bends more, refractive index is more. If light hardly bends, then the refractive index is less. So how much is the bending of light is what you should see. In the light pink, it has bent the most. In the green, it has not bent the most. It has bent the least. So mu is minimum. Is that okay? The green one is the least refractive index. Okay. No, no. There is one critical angle for a refractive medium, correct? But that is what we do not know the refractive index. So we are trying to find out the critical angle. So, this is going to give me the least value of mu for that critical angle of incidence. Think of it like that. So now this is going to be a very simple thing now. So I want to just going to draw this particular normal. I'm just going to draw this normal, and this is obviously 90 degrees is the angle of incidence, I can say. And this angle, obviously, this is a 90-degree, 45-degree triangle, as you can see. So this particular angle over here is 90. So this angle as well as this angle, both will be 45 and 45 degrees. So needless to say, if this is 45, since this is 90, yep, this is 90. So that means even this angle is 45 degrees. This I can take it as the angle of refraction. Angle of refraction. So using Snell's law, sine of I by sine of R is the refractive index. Sine of 90 by sine of 45 is mu. Sine 90 is 1, sine 45 is 1 by root 2. So therefore, root 2 is equal to mu. So root 2 is the D option for IIT Delhi. Brilliant question, isn't it? Brilliant question. Loved it? It's actually not difficult. If you see the solution, it is such a laddu solution. But analyzing which will give you minimum refractive index is the crazy part. Guys, if the question was maximum refractive index, then even better than pink will be, there will be some other line which will probably go like this, very close to C, and it will go like that. So that will give you highest possible refractive index. Is that right? So that will be having highest possible refractive index if the light is reaching till here and bending the most. It's like almost turning by 90 degrees. That's going to give you a crazy refractive index of infinity. Yeah, that's going to be very, very high refractive index tending towards infinity. Let's solve this question. Okay. Now this question also, use of geometry. The moment you see such questions, you should think, okay, yes, sir, geometry will be used. Oh, you got this question right with Tukka strategy, but every time it will not work. So don't be completely dependent on your luck. It's good that it worked in January. You never know what happens in April. Okay, so always stick with logic. So there are two light beams which are falling theta1, theta2 with the surface. Okay, after refraction, the beams intersect at this point 3, exactly opposite at the midpoint. Okay, given the distance between 1 and 2, yeah, between these 2 points where the light is falling on this slab is a D, and the D is 4 root 3. Okay, theta 1, theta 2 are equal to N2 by N1. Okay, N2 by N1 refractive indices basically, where the refractive index of the block is more than the outside medium. The thickness of the block is how much? Okay, so let's start drawing the diagrams on how the rays will look like. Okay, so obviously the ray will go and hit over here. This ray will go and hit over here like this. Let me also show the normal. Let me also show the normals. This is the normal. This is the normal. All this will be needed. And I will also need this particular angle and this particular angle over here. Let's say I just call this refractive index. Sorry, angle of refraction. I can just call it theta 1, theta 2 is there. So I will use theta 3 only then. I'll just use theta 3 because I'll just keep the angles as theta only. Is that okay? Fair enough. All right. Now what should happen because of symmetry? Obviously, this will be also theta 3. Okay. This point 3 is exactly opposite. Entire diagram is symmetrical, guys. Yep, entire diagram is symmetrical. They have to meet exactly over here. So let me draw a perpendicular now from here and see what I can do. The moment I drop a perpendicular, this is 90-degree. So this much distance, I think I can find out. I think I can analyze this triangle and somehow I can find the thickness of the block. Oh, the thickness of the block means this dotted line, which I will call it as T. The question is find the value of T. Question is find the value of T. Can I find this distance? And if I find the distance, my job will be done. I'll tell you how exactly also. See, this is theta 3. The two dotted lines are parallel and this is an intercept. So alternate angles will be equal. So even this angle should be theta 3. Everybody agrees? These are like two parallel lines and an intercept over here, correct? So this angle should be equal to this angle. So I'm just using the properties of parallel lines and intercept over here. And I can see this small little triangle. I just need to find this side and this angle. I think my job will be done. So this is D. This is obviously going to be D by 2. D is 4 root 3. 4 root 3 by 2. So this will be 2 root 3. So this is 2 root 3. So to find this, I just need this angle and my job is done. So how do I find that particular angle? Okay, so let's use Snell's law now. Snell's law. Now remember, this is your angle of incidence. This is your angle of refraction. So sine of I by sine of R is refractive index. Light is going from 1 to 2. Light is going from outside to inside. Incident angle, check it out. It is 90 minus theta 1. Lot of people took the angle as theta 1 itself. No, always the angles have to be measured from the perpendicular, all the normal drawn. Good morning, Dia. Yeah. Yeah, the thickness of the block is the altitude. Correct. The thickness of the block will be the altitude, that orange dotted line. Correct. Okay. Awesome. Okay. So now, what is sine of r? Sine of theta 3, of course, which I need it eventually. N12 will be N2 by N1. I just gave you the formula. Okay. So this is nothing but cos theta 1 by cos, sorry, not cos, by sine of theta 3 is N2 by N1. But there is something interesting given over here. Yes, use that. From this, I can clearly see cos theta 1, if this is cos inverse, cos theta 1 will be N2 divided by 2 times of N1. Just take the cos on the other side. So cos theta 1 will be N2 divided by 2 times of N1. Perfecto. And this is nothing but sine of theta 3, okay, is equal to N2 by N1. Okay, so N2, N2, N1, N1 gets cancelled. So 1 by 2 is sine of theta 3. Oh, immediately I will get theta 3 as 30 degrees. Sine 30 is half. Oh, I found out the angle, guys. There is nothing great left in the problem. So if sine is known, I can find, or sorry, the angle is known, I can immediately find out this height by using trigonometry now. Just write tan theta 3. Opposite side is 2 root 3. Adjacent side is that thickness. Tan 30 is 1 by root 3. This is 30 degrees. So tan 30 is 1 by root 3. So 2 root 3 by t. So take thickness on the other side. So 2 root 3 multiplied by root 3, which is 2 into 3, which is 6, which is 6 centimeters. So answer is 6 centimeters. Wow, we got it. So guys, pure geometry. As you can see, Snell's law was just one simple laddu initial part. Rest all was mathematical manipulations, trigonometry, geometry. That's it. Very good. Great, great. Are you loving these questions, guys? Shall we go to the next one? Refraction through a glass slab. Refraction through a glass slab. Now, I don't know how many of you have realized this by now, but I will tell you one interesting thing which will literally blow your mind. Yeah. See, guys, if you take a slab, if you take a slab, and if there is a ray which is incident on it, then you will see that the ray will refract, and by the time it comes out, it will be like this. And if this was the incident ray's direction, you will see that the incident ray and the emergent ray are parallel. So there is no deviation. There is a parallel shift. There is a parallel shift. There is a parallel shift. Yes. Or basically, I will also call it as a lateral shift. Lateral shift. The ray gets shifted and it comes out the moment it passes through that particular glass slab. Is that okay? The moment it passes through the glass slab. If the thickness of that particular slab is, let's say, T, and the refractive index is, let's say, mu, and you give me the angles, let's say this is I, and let's say this is R, that particular lateral shift, what is the formula? Thickness is there. Yep. What is there on the top? You have sine of I minus R. How many of you remember this? Yes, sine of I minus R. Sine of I minus R. And here you have cos of r in the denominator. So this is an important formula. This is a very important formula of lateral shift, and obviously there is no deviation. The ray is still in the same direction. But the moment the surfaces are not parallel, you will immediately see that the ray which is going to be falling will get refracted, and it will not exactly emerge parallelly. It will have some angle, and angle with the incident ray. So definitely there is a deviation which occurs. The deviation is not zero. You will learn it later in the prisms also. It is A into mu minus 1. This is for thin prism. This is for thin prism. The moment the surfaces are not parallel, they are making an angle, there is a deviation which occurs. If the surfaces are parallel, there is no deviation. Is that okay? And if you take a normal prism where it will have sufficient space, enough angle for it to deviate, enough space, enough angle to deviate. The deviation is quite large. Yes, this deviation is quite large, and you will see that it is incident angle plus emergent angle minus the angle of prism. So this is for a normal big prism, for a normal prism, for a normal prism. This is basically that angle of the prism. Over here, you have the incident angle, and over here, you have the emergent angle. These things you should definitely know. If you have the Vedantu Tattva, it is good enough. Please practice those level 1 questions and few level 3 questions, level 1 and level 3, and the PYQs. The PYQs of JEE Mains, which is the level 2. So few questions of level 3. Level 1, only those topics which you are not comfortable with or you need that full confidence. Level 2, please practice as much as you can. Okay, that will give you a good hold on the subject. Okay, so this is very interesting to see how the parallel nature of the surfaces affects the deviation in different scenarios. So let's start taking some questions. What is the lateral shift if the thickness of the slab is h, refraction is r, incident is I, the slab is placed in an air medium? Guys, can you believe this question came? Now everybody spam the answer. Let's see how many of you are attentive. At least they could have given some values and then it would be fine. But they decided, no, I will not even give you values. I'll just ask you the formula. Can you believe it? The lateral deviation derivation is asked in the board exam. Yeah, but don't worry. This is your JEE exam. They will not ask you. Yeah, come on, everybody. Everybody spam. It is not H. Cos, sine, tan, sine, cos. Always sine on the top, cos below. Sine, I minus R, and cos R. Everybody spam the answer. What are you guys doing? Sleeping. Come on. Just now I showed you this. Thickness sine I minus R by cos R. So here the thickness is replaced by alphabet H. There is only a difference of the alphabet. Correct. Venkatachari, good afternoon, my dear. Okay. So sometimes they can give you the values, they can give you the refractive indices. You just have to substitute in this formula and get the answer. So the questions are very simple. There is nothing great about it. Okay. The question of critical incidence, just quickly revising through that particular concept, my dear students. If you have a dense medium and a rare medium, then usually what happens when you pass the light, then the light will come out from the rarer medium at a larger angle, and it will also get reflected. If you change the angle, make it slightly big also, doesn't matter. Even if you make it big, still you will see the light will come out and it will also get reflected partially. But there comes an extreme angle, a critical angle, where when you incident the light which comes out is almost grazing the surface. It's almost like parallel to the surface. Yes, the light is getting reflected also. But beyond this, if you choose any angle, beyond this, if you choose any angle of incidence, the light will not be able to come out. It will just get reflected over here. You can choose any angle after this. Yep, the light will just get internally reflected. So here onwards, which is that one, the orange onwards, this angle of incidence, this particular angle of incidence is called as the critical angle of incidence. This ray which is coming out, it is called as grazing the surface. This is making 90 degree. Before this, there was partial reflection was occurring, and partial refraction was also there. Partial refraction was also there for all the angles which are less than your critical angle. Less than your critical angle. The moment your angle becomes more than the critical angle, nothing is coming out, all the rays are getting reflected, so it is no longer partial, it is total internally only it is getting reflected, internal reflection. So TIR, that's how it comes. TIR, total internal reflection. This is your critical angle of incidence, and the formula for that critical angle of incidence, it's also written over here, but still I will write it down. Sine of that critical angle is 1 by refractive index of the dense medium with respect to that rare medium. Basically, the refractive index of this lower medium, you have to take it. That's all. So this is the formula which you should know. Is that okay, everyone? Clear? Yes, Mithun, this one shot is the most important one shot, because after this you will understand most of the concepts. You will get a hold of the application part of the formulas and the theory. You will practice a lot, which will help you develop your analytical skills. You will also understand maybe this topic I need to research or solve more. So at home, please solve those questions of that topic where you are not confident. That's all. So other than that, this one shot will be more than enough. Okay, great. So let's start solving some questions, guys. Coming up on your screen. Critical angle of incidence for a pair of optical media is 45 degrees. The refractive indices of the first and the second media are in the ratio of, very straightforward. So it is clearly mentioned that the critical angle is 45 degrees. So we know the formula. Sine of IC is 1 by mu. So therefore, sine of 45 is, this is dense medium with respect to rare. So dense medium with respect to rare. Sine 45 is 1 by root 2. This is 1 by refractive index of dense with respect to rare. So refractive index of the dense with respect to rare is root 2, taking reciprocal. But what is this? This is nothing but mu d by mu r. 1 mu 2 is mu 2 by mu 1. So that is root 2. Yeah, so that is basically root 2. So the refractive index of the first and the second. What is the first? It is obviously the dense medium. What is the second? It is obviously the rare medium. So that the first by second is root 2. So answer is D, not B. Many people found that confusing in the exam. Yeah, many people wrote B option. Be careful. Very good. Excellent. So these are the kind of questions which can be asked. Okay. I have seen also one question where they had coupled with Brewster's law, and they had told that the critical angle, is 30 degrees. Can you find the Brewster's angle? Such questions also have come. Okay. So some angle they will give, critical angle is 30 degrees. Can you find the Brewster's angle? So we know the formula for critical angle is 1 by mu. So sine of 30 is basically 1 by mu. So half is basically 1 by mu. So mu is basically 2. So what do we do with this? There is a Brewster's law which is there in your wave optics, which says that light which is unpolarized, when it falls on a dense medium, the reflected light is completely polarized if it falls at the Brewster's angle. And that Brewster's angle, tan, is the refractive index. So this is related to the polarization of light concept. So then you will just say tan of theta b is basically mu. Mu is nothing but 2. So theta b, Brewster's angle, will be tan inverse of 2. So that is your answer. So the Brewster's angle is tan inverse of 2. Is that absolutely clear, my dear students? Everyone? Yeah. So this is with respect to that Brewster's law. Those of you have forgotten, let me remind you. So if there is a dense medium here, this is a rare medium. Then if you have light which is falling like this is the refracted light. This is the reflected light. This is the incident light. This is your Brewster's angle. This is unpolarized light. So the planes of oscillations are in all possible directions. If it falls exactly at this angle, the reflected light becomes polarized. This becomes polarized. And when that happens, the reflected ray and the refracted ray are perpendicular to each other. Very, very important. The reflected and the refracted rays are perpendicular to each other. So this is your Brewster's law. Is that okay, everyone? Fine. Shall we now go to the next concept? Okay, let's go. Refraction at curved surface. Plane surface is done. Let's go to plane surface. Okay. Sweda, chill. Chill, Madi. What are you guys saying? I will do suicide if I get fail. What do you think? If you fail the exam, life is going to be useless. Not at all. So many students fail. What, their life is useless? They will do something in life. So don't judge your life by a exam. I know you have heard this many times, but it is actually the truth. See, I am a JEE teacher. I myself cleared JEE. I've done, all the things from NITs and IITs. I've sent so many students, but still I tell, it's okay. If you don't get it into IIT, I mean, how can that be even a thought? I mean, think about it. Like, really, after, I don't know how difficult it is to be born as a human being. I mean, you think life as a human being, giving exams is tough. Just imagine you are and not being born as a human. Maybe you are a frog, or maybe you are a deer, or even some other animal. It's so tough, guys. There, you have to survive to live. Here, you don't have to survive. Nobody is trying to eat you. Nobody is trying to kill you. Nobody is trying to hunt you down. So many crazy things happen in the animal kingdom. You are at least a human being. You can enjoy life. You can enjoy whatever luxury is there around you. You can enjoy whatever beauty is there around you, the nature around you. You can taste, you can smell. I mean, and when God has given you such an amazing gift of life, throwing it away should be the biggest sin. So there is no mercy for such things, guys. So please put such thoughts away. Think about your parents, think about your friends, and there is a bright, bright future ahead. Yeah, got it? Yep. So we will try our best to get into JEE, but there are a lot of options. I mean, making videos, other options apart from JEE. Guys, watch that video. So many options are there. Why do you want to think about such negative things? All right. So what is the formula over here? If you have one side if you have one side of one medium, other side of other medium, and these two mediums are separated by a curved surface, so the light which goes will get refracted. There will be many rays of light like this. They will form an image. If there is an object here, they will eventually form an image. This will be the object distance. This will be the image distance, right? This being the curved surface, this will have a radius and this will also have a center of curvature. So this will be the radius of curvature. This will be the center of curvature. This is object distance. This is image distance. The formula goes as follows. Formula goes as follows. Mu2 by V, second refractive index. So this is mu2, guys. This is mu2 by image distance. By image distance. A minus mu1, the first refractive index by object distance, is mu2 minus mu1 divided by the radius of curvature. Divided by the radius of curvature. Remember, this is the center of curvature. This was your pole. Is that okay? Please remember this formula. Now, there is also the formula for magnification. I don't know how many of you know this. The magnification, which is height of the image by height of the object. Well, guess what the formula is? It is V by U, but with V, who is coming? Mu2. So, V by mu2. So, put V by mu2. With U, who is coming? Mu1. So, U by mu1. U by mu1. So, that is what the formula is for magnification. There is no minus sign over here. Please keep that in mind. So, remember this. Sometimes it might be useful. You never know. Okay. Great. Now, let's see some questions based on that. Okay, if you learn the application, that is more than enough for solving these questions. A spherical surface, some curvature, is separated by air and glass. Glass refractive index is 1.5, air is 1. The center of curvature is in the glass. Point object is in the air on the axis. So real image is formed inside the glass. OI intersects the surface at P. PO is equal to PI. Distance PO is equal to. Now, if you try to imagine it, it is crazy. So don't try to imagine and visualize. Just draw. If visualization is weak or average, just draw the situation. Okay. So let's imagine a spherical surface like this. Okay. Let's also draw the optical axis like this. Okay. So this is your center of curvature. This is your pole, of course. The object O is placed in air. So object is in air. So this is my object. So the object is in air. Okay. The real image is formed inside the glass. OI, the line OI. So this is O and I. What is I? Wherever the image is. Intersects the surface at P. Okay, that is also there. PO is equal to PI. So whatever is the object distance is the image distance. So if this is I, where the image is, as per the given question, if this is X, even this is X, as per the question, PO is equal to PI. So what is this PO distance is the question. Well, let's try to solve it. First of all, the refractive index over here, this is 1.5. This refractive index is 1. This is the first refractive index because the rays will come from here. So this is mu1. It is entering here. So this is mu2. Okay. Everyone fine till this point? Right. So let's use our formula which says second refractive index by image, first refractive index by object is second minus first refractive indices by radius of curvature. Second refractive index is 1.5. Image distance positive x. Remember, this side will be positive, this side will be negative. Rays from the object will go like this. So this side is positive. So it will be positive x minus mu1 is the first, which is air. Object distance will be negative x. So 1.5 minus 1, same order. Radius, well, center is on the positive side, so it will be positive r. Is the sign and the substitution absolutely clear? Yep. Is the sign and the substitution absolutely clear? Everyone? Okay. Now, what is 1.5? That is 3 by 2. Okay. X minus minus is plus. So this is 1 by x is equal to 0.5. 0.5 is half. So half times of r. Okay. So 3 by 2 plus 1 is 5 by 2. So this will be 5 by 2x is equal to 1 by 2r. 2 cancels. So 5 by x is equal to 1 by r. So what is it? I want x, right? So x will be 5 times of r. So the distance PO, x will be 5 times of r, which is option A. Yes, option A is the correct answer. So the distance OP, which is equal to x, will be 5 times of r. That is the answer. Everyone, option A, very good, Abhirani. Great, awesomeness, awesomeness, guys. Let's go to the next question on your screen. There is a long tube mixture of two liquids with refractive indices forms convex refractive meniscus towards A. If object is 13 from the vertex of A, forms an image with magnification -2. See, magnification related question. Radius of curvature of the meniscus is. Okay. So let's try to solve this. Tube, mixture of two liquids A and B. The convex surface is towards A. Convex surface is towards A. Okay. So this side is A. This side is B. A has a refractive index. Mu A is having 1.3. Mu B has having 1.4. Okay. So this is our principal axis. The radius of curvature is asked. Object is placed 13 centimeter from the meniscus A. Okay. So this is where the object is. This is the object, and this is 13 centimeter. This is your meniscus, and it forms an image with magnification -2. Okay. So that's all that is given to me. Okay. So till this point, is the diagram clear? Is this diagram absolutely clear, my dear students? Okay. Yes, sir, it is clear. So now, wait a minute. We'll try to find out using magnification formula certain things. Magnification formula was V by mu2 by U by mu1. Okay. So this is -2. Image distance, I do not know. Mu2, I know is 1.4. Object distance, -13. Mu1 is 1.3. Okay. Minus is cancelling out. Okay. So therefore, 2 is equal to V divided by 1.4. And there will be 13 over here and 1.3. Now 1.3 goes with 13. This will be 10 times. 10 into 1.4 will give me 14. So therefore, V will be 2 multiplied by 14. So it will be 28. So check this out if it is 28 centimeters. Image distance is 28 centimeters. Is this point absolutely clear? Okay. Now let's use our curved surface refraction formula, which is mu2 by V minus mu1 by U is mu2 minus mu1 divided by R. What is mu2? Second guy, 1.4. What is image distance, which is 28 minus mu1? What is it? It is 1.3. Object distance minus 13. Okay. Mu2 1.4, mu1 1.3, and the whole thing divided by R, guys. So now 1.4, 14 goes with 28 two times, but there is a decimal. So 1 by 2 multiplied by 0.1 minus plus. So 13 goes with 1.3 10 times. So this will be 0.1 directly, okay, on the top, and is equal to, this is 0.1 again divided by R, of course. 0.1 cancels. So half plus 1 is equal to 1 by R. So 3 by 2 is equal to 1 by R. So therefore R is equal to 3 by 2 of a centimeter. So 3 by 2 of a centimeter. Just check it out. If I think we have got the exact opposite answer. Oh, sorry. I have to reverse it. My bad. I have to flip it. So this will be 2 by 3 centimeter. My bad. Yeah. So this is correct. Awesome. Love the question, guys. Yeah. So this was a good question on the magnification of curved surface refraction. Beautiful question. Shall we go ahead to the next one? Lens maker formula. Let's quickly revise it. If two surfaces, curved surfaces of a lens are given, and you have to find what is the focal length, then the focal length formula is 1 by f. F is the focal length. Relative refractive index -1, 1 by R1 minus 1 by R2. This term over here is the relative refractive index of the lens with respect to outside medium. So it is always, you will see, refractive index of the lens. This is of the lens, and this is of the outside medium. Always keep that in mind. Also, sign convention has to be applied for R1 and R2. Very important. Just to give you an idea, say I take all the possibilities, this, then this, then this, then this, or let's say even this. Okay, what is the sign convention? Here, see, light will enter from everywhere. Light is coming from the left side. Everywhere light is coming from the left side. It is touching this surface first. So this is our first surface, guys. This is our first surface. So this is our first radius. And then this is our next surface. So this is your second radius. So because R1 is on the positive side, it will be positive. R2 is on the negative side, so it will be negative. The same ray continues going like this. This is our first surface. This is our first radius. So this is your negative side, that is positive. So R1 will be negative. This is your second radius. R2 is on the positive side, so positive. Here, the first surface is flat. The first surface is flat. So R1 will be infinity, and the second surface is here. The radius will be like this. So R2 is again on the negative side. So it will be negative. Here, this is the first surface. So this is the radius 1, which will be obviously negative, which will be negative. It is on the negative side. This side is positive. This is a flat surface. So R2 will be infinity. R2 will be infinity. Flat surfaces are always infinity radius. Here the light is coming like this. So this is our first surface. So this is R1. It's on the positive side. This is your second surface that is also on your positive side. So this is positive. So that's how you choose the signs. Is that okay? Shall we go ahead? Now I hope you know how to use the lens maker formula. Let's solve some questions based out of this, obviously. Okay. So I think this was just for plano convex lens. We just did that. Let's solve a question. For the thin convex lens, the radii of curvature are 1530, the focal length is 20, the refractive index of the material is. Okay, so let's imagine a thin convex lens. And of course, if the light is coming from here, this will be the positive side, this will be the negative side. This is the first surface, so this will be R1, which is 15 centimeters. And this will be the second surface, which will be on the negative side. So R2, R1 will be plus 15 centimeters. R2 will be what? Minus 30 centimeters because it is on the negative side. Does it matter if I take 15 here and 30 there? If I change the order? No. Even if you flip the lens, even if you take the first surface second, second surface first, the focal length remains the same. Please remember this. This is a very important property. A lot of people do not know this. If I take this lens, okay, like this, or this lens like this has focal length f, this also has focal length f, or for that matter, this and just this, or let's say this, or even this, both of them have the same focal length. If this is f, this is also going to be f only. Yeah, the focal length does not depend on how you place the lens, like that. All right, so let's find out the focal length now using lens maker formula. 1 by f is relative refractive index minus 1, 1 by r1 minus 1 by r2. Focal length of that lens is 20, so 1 by 20 is mu minus 1, 1 by 15 minus 1 by minus 30. So this is mu minus 1, 1 by 15 plus 1 by 30. LCM is 30. So this will be 2 plus 1, 2 plus 1, which is nothing but 3. So 3 by 30 is nothing but 1 by 10. So that is 1 by 10. This is mu minus 1 is equal to 1 by 20. 0, 0 will cancel. So this is 1 by 2. Okay. So is equal to mu minus 1. Take 1 on the other side. So 1 by 2 plus 1 is equal to mu. So 3 by 2 is equal to mu. So mu is 1.5. So 1.5 is option B. Yes, that's correct. Very good. Excellent day. Awesome. Awesome. Wow, Siddhi Khandelwal is our rookie member. Wow, and we have started some membership, guys, and we'll be, uh, giving some nice special content for all our members also very soon. So you might have seen, apart from the subscribe button, you can also see there is a join button. So join is a special membership. So we'll be doing something special for you guys too very soon. Okay, let this exams come and go, and then we'll do. Okay. Moving on. Next one on your screen. Here it is. A plano-convex lens having radius 2 exhibits f1. Another plano-convex with flush surface radius 3 has focal length f2 when it is immersed in the refractive index of 1.2. If both lenses are made of same glass of refractive index 1.5, the ratio of f1 and f2 will be how much? Okay, so let's start with the first one. A plano-convex lens having first surface 2 centimeter. Okay, so this is our plano-convex lens like this, and the radius is 2 centimeters. Both of them are immersed in a liquid. They are made of same glass, refractive index 1.5. What is the ratio? So 1 by f1 will be relative refractive index minus 1. 1 by r1 minus 1 by r2. So this is going to be R1, of course, but the value of R2 will be infinity because it is a plane surface. The first surface is fine, but the second surface will be infinity. So 1 by F1 will be lens has a refractive index of 1.5, medium has 1.2 minus 1, radius 1 is 2 centimeter, infinite radius for the second surface. So 1 by f1 will be 1.5 by 1.2 minus 1. Actually, both of them have the same focal length, same outside medium. So for the other lens, if you take the other lens, let's say, which has 3 centimeter, the only difference will be this will be still 1.5, this will be 1.2 minus 1, this will be 1 by 3, and this will be 1 by infinity. So when I divide both of them, think what will happen. So divide both of them. I'll have 1 by f1, and here I will have 1 by f2. This and this will get cancelled. So I'm just left with 1 by 2 minus 1 by infinity upon 1 by 3 minus 1 by infinity. But wait a minute, 1 by infinity is 0. 1 by infinity is 0. So technically this is 1 by 2 by 1 by 3. So this will become f2 on the top, f1 below, 3 on the top, 2 below. But I want f1 by f2. So that will be 2 by 3. So 2 by 3 should be the answer, which is option. I think 1 by 3 is wrong. Yeah, it should have been 2 by 3. Yeah, 2 by 3. Everybody with me on this? Clear? Awesome. Awesome. Yeah. Can you explain the sign convention? Again, Anand, thank you so much. Thank you for all the love from Kerala. So I'll tell you the sign convention. Where did it go? Here only, no? See, just check what the surfaces are. This is the surface of a convex lens. Example, the light is coming like this. So naturally, this becomes our first surface. So if you draw the radius, this will be radius 1. This becomes naturally the second surface. So obviously, this will become the radius of curvature 2 because the light is coming like this. So this side will be positive, this side will be negative. Hence, since R1's center is here, so this will be positive. Since R2 center of curvature is here, so R2 will be negative. Understood how the sign convention works? Only when there is a flat surface, curvature is infinity, because in a flat surface can be thought of a circle which is so large of infinite radius that it will never turn. You have to go infinitely large distance. So R will become infinity for plane surface. Is that now clear? Yeah. Awesome. First lens is in air, second lens is in liquid. Oh, is it? Did we miss that part? Okay. Another plano convex lens has focal length immersed. Oh, sorry guys. Sorry. So much. This will be 2 by 3 only if both are in liquid. I'm so sorry. See, silly mistakes happen like this. My bad. This is in air. Yeah, this is in air. So we need to be careful. So in the first case, this will not be there. Second case, this will be there. Yep. Ma'am. So there is air in this case. In this particular case, there is some liquid in which it is immersed. It is immersed in a liquid, or this particular lens. So when I divide, this will actually not cancel. So let's try to divide and see what do we exactly get there. So let's divide. So 1 by f1 minus 1 by f2 will be 1.5 minus 1 upon 15 by 12. I will put it 15 by 12 minus 1. Here I have 1 by 2 minus 1 by infinity, and here I have 1 by 3 minus 1 by infinity. 1 by infinity is 0. Yep, 1 by infinity is 0. This will be f2 by f1, correct? And this is nothing but 0.5, which is nothing but half. 0.5, which is nothing but half. 15 goes with 3 5 times, 12 goes with 3 4 times. So technically this is 5 by 4 minus 1. This will be 1 by 2 by 1 by 3. Okay, so half is there. So half is there, and 5 by 4 minus 1 is nothing but 1 by 4, and this will be 3 by 2. Again, 4 goes on the top, 2 comes below, 3 by 2 will come over here. This 2 and this 2 will cancel. Yeah, and this 2 and this 2 will cancel. So this will become 3. So this is nothing but f2 by f1. So f1 by f2 will be 1 by 3. So then it will be B option, which is correct. Yeah, perfect. So then it will be 1 by. Is that okay, everyone? That's how you can solve it. So here the first lens was in air. So that's why the first medium I have taken 1. For the second lens, instead of dividing it by 1, I have divided it by 1.2. Always the refractive index of the outside medium should be taken. Great. Awesome. Cool. Let's go. Let's go to the next question, guys, coming up on your screen. And here it is. What does it say? There is a thin convex lens, and each side having R, one side is polished for complete reflection. Okay. At what distance from the lens an object be placed on the optical axis so that the image. Okay, actually this we should do it after combination of lenses, but even then I will just do one thing. Just remind me that we have to get back to this particular question. I'll just put a star mark. After we discuss combination of lens, I think this slide came much before than expected. Okay, just will come back. Just will come back to this particular slide. A plano-convex lens is immersed in a liquid when the plane side is silver coated. I think uh, these questions, I'll just come back, guys. I think they have come before. Just 1 second. After we discuss combination of lenses, we'll come back to this. Okay, after we discuss combination of lenses. Let's first learn the lens formula, magnification, and then the power of a lens and combination, and then we'll come back to that. Okay, so again, now the lens formulas. We just saw what is the focal length of a lens using lens maker formula. Where is the image formed by a lens? It is given by just the lens formula, where the image is formed, and it is given by 1 by V minus 1 by V U is equal to 1 by F. Yes, this focal length depends on the refractive indices. This is your lens formula. Magnification, this is your lateral or transverse magnification, is given by height of the image upon height of the object, which is just V by U. The longitudinal magnification, which is length of the image upon length of the object, this is along the principal axis, is the image velocity by the object velocity, which is negative v square. Sorry, negative is not there. It's just v square by u square. These are the formulas. Okay. Do you see they are very much similar to the mirror formulas, just that the signs are exactly opposite. In mirror, there was negative v by u, that minus is not there. In mirror, this formula had minus v square by u square. It has now become plus v square by u square. Mirror had 1 by v plus 1 by u. Lens will have 1 by v minus 1 by u. That's it. That's the only difference. Is that okay, guys? Is that okay? Very good. Very good. Cool. So let's use these formulas and these particular questions. There is a photograph of a landscape. This was one of the best questions. And the camera is at height of 18 kilometers. The size of the film is this much. The area of the landscape is 400 kilometers square. The focal length of the lens of the drone camera is? This was one of the best questions which was asked on the lens formula. Okay. Lateral is for, see, this is the principal axis, this is the lens. Height wise is lateral, longitudinal is for lengthwise, meaning say this is your object. Maybe it becomes like this. So this is your length of the object. This is the length of the image. This is the height of the image. This is the height of the object. Understood? This is your principal axis. This is your principal axis. So how much does this expand is longitudinal magnification. Is that clear? Oh, okay, cool. So let's solve this particular question. Now in this particular question, let's assume that our drone lens is somewhere over here. Okay, and it is going to photograph 18 kilometers away. So that particular thing which it has to photograph is somewhere over here, and the image will be formed on a small camera lens which is over here. So this particular distance is given to be 18 kilometers. 18 kilometers. And this distance, can you guess how much will it be? This will be exactly the focal length, because this is very, very far away. This is very, very far away object, and the rays will converge close to the focal length. Okay, and it will be a very small image over there. Do you guys agree with this? Do you guys agree with this statement? Yep, very good. Now let's think more. Focal length of it is asked. In fact, that is what is asked. So this is your lens basically. This is, sorry, not the lens. What is it? The size of the camera film. This is the film. This is the camera film. This orange one is your lens. This is the lens which will focus all the rays. Now, since the area of the landscape is 400 kilometers, I think I need to look at it in linear dimensions than aerial dimensions, because we have been asked the focal length, the size of the camera film is given. So if this is 2 centimeters by 2 centimeters, 2 centimeters by 2 centimeters means it is something like this. Just imagine it to be like this. That film is like that. Same thing, even that area will be like this. So my point is, if the area of that landscape is 400 kilometers, what will be the side of that particular area or that landscape? What will be the side? It will be side square is 400 kilometers square. Therefore, that side will be 20 kilometers. Do you guys agree with this? The side will be of that object will be 20 kilometers. Will be 20 kilometers. Now, I have one more proposition over here. If I draw this line and this line, basically your ray diagram, I can see some similar triangles over here. So when you have similar triangles, when I have similar, right angled triangles, right angled triangles, the sides will be in the same ratio. So the linear sides in same ratio. That's the property of similar triangles. So this by altitude or by hypotenuse and height, whatever sides you take, they will be in the same ratio. Is that right? Okay. So what do I know? What do I want? If I take this side by this side and the height by this height, they should be the same. So how about the base ratio will be equal to the height ratio of the triangles. The base is example 20 kilometers by the base over here, that is 2 centimeters, will be equal to height ratio. This height is 18 kilometers divided by this height is f centimeters. Centimeter, centimeter, kilometer, kilometer. They basically cancel off. Everybody can see that? Everybody can see that? Awesome. So what will this happen? 20 by 2 is basically 10. This will be 18 by f. Therefore, f will be 18 by 10. Therefore, f will be 1.8 centimeters. The focal length is 1.8 centimeters, which is a D option. Isn't it an amazing question? A faraway object makes the image on the focal plane. The area was given, so I found out the side. The side was 20 kilometers. This was 2 centimeters. These are similar triangles which will be formed if you complete the ray diagrams. That's it. Remember, a ray passing through the optical center goes undeviated. Ray passing through the optical center goes undeviated. That's how I have drawn the ray diagram, and that's it. Yeah. I hope this is absolutely clear. Warrior Whitey, I think many students are busy solving the questions, so I can see the chat rate is little bit slower than usual. If that is the case, good. But if you guys are scared to answer, don't be scared, guys. Please interact. I mean, the more mistakes you make, the more things you talk, more doubts you discuss, the more questions you ask with each other and help each other, that is going to benefit you. Don't think, oh, why should I tell somebody else? Who is that person? I don't know the people here. No, don't think that. Guys, trust me on this. The whole community is for you. If everybody starts thinking, oh, I should not help, then nobody will progress. The whole Vedantu J English community, why students do so well in this particular channel is only because obviously we have given quality content, we are very regular, everything is there, teachers are great, but also students help each other in the comments, in the chats, and everything else. So you need to do that. You need to step up. Yeah, yeah, it was definitely a nice question for sure. Correct. Hmm. So what is the next one? What is the relative decrease in the focal length of a lens for an increase in the optical power by 0.1 D to 2.5 diopters? So D stands for diopter. Relative decrease in the focal length. Okay, so see guys, uh, in lenses, right? The power of a lens is just 1 by f. As simple as that. It is not minus 1 by f. For mirror, it is negative 1 by f. For lens, it is positive 1 by f. Always the signs will change. So, coming back to this particular question, because we know power is 1 by f, f is 1 by p. So let's do this 2 times. So first time, focal length will be 1 by zero point 0.1, which is 10, but this is meters. So focal length 1 is 10 meters. Focal length 2 will be 1 by 2.5. 2.5 is nothing but 5 by 2. 5 by 2, which is then going to be 2 by 5. So F2 is going to be 2 by 5. Yeah. So 2 by 5 of a meter. But the question is, what is the relative decrease? So if that is the question, so the relative decrease is the change in the focal length upon uh, the original focal length. Original focal length was f1. Okay, delta f. So delta f means the difference of these two. So 10 minus 2 by 5 upon the original focal length, which is basically 10 right over here. Okay, so this will become 10 and 10 will cancel. It will become 1 minus 2 by 50. So what will this become? 50 minus 2 is nothing but 48 by 50. Just check this out. Just check this out. What is the relative decrease? That's what they have asked. For a lens 0.1 to 2.5D. First focal length is 10 meters. Second focal length is this much. So the change is not much relative decrease. This is the decrease 10 minus 2.5 divided by 10. 10 by 10 is 1. 2 by this is 50. 50 minus 2 is 48. So 48 by 50, guys. Just check this out if this is correct. Yeah, but doesn't seem like anything is matching over here. What is the relative decrease? Anything else that we have missed? Just check it out. Mm, Original focal length was definitely 10. Oh, sorry, guys. My bad. I tell you, increased by optical, there was an increase in the optical power by 0.1 D from 2.5 D. So, my bad, guys. This is slightly wrong. Increase in the optical power was 0.1 D. It was not 0.1 D. The increase was 0.1 D. So sorry. So sorry. I'll tell you what. This f is p raised to minus 1. We have to do it actually by errors now. There is no other way. So if you take the relative error of f, that will be minus 1's modulus, always take the mod value, into delta p by p. So they have asked the relative change of the focal length, which will now be just delta p by p, where delta p is 0.1 and p is original power, which is 2.5, which is 1 by 25, which is 0.04, which is option A. Let me check. Yes, that is correct. So initially, I really mistook this particular thing, the statement. This was not initial, this was not final or anything. The change is zero point 0.1. So delta P is 0 0.1. This was your original power. And then they are asked the relative decrease in the focal length means the change upon that original. That is what they have asked. Is this clear? So this is technically a question of errors and measurement, relative error analysis. Correct. Very good. Shall we go ahead to the next question on your screen? Here it is. When an object is placed at the center of curvature of a concave lens, image is formed at the center of curvature of the lens on the other side. Concave lens always forms virtual erect image. What do you think about these statements? I want to see everybody's answer in the chat box right away, right now. Come on, guys. Everybody's answer right away, right now. Yeah. When an object is placed at the center of curvature of a concave lens, the image is formed at the curvature of other side. There is no such rule. Actually, it is if the image is formed at, sorry, object is placed at 2f, image is formed at 2f, but 2f is not center. That is only for mirror, not for lens. So don't get confused and say, yes, that is true. No, they have tried to play with your mind. They make you think, oh, 2f is R. No. 2f is not R for lens. It is only for mirrors. So this is definitely wrong. And concave lens always forms a virtual yes, because if you take a concave lens, if you place an object, the image will be here. It is erect and it is virtual. So this is also perfectly fine. So A is false, B is true. A is false, B is true. So option A. Next one. To measure the focal length, the object position, image position, the errors are delta U and delta V. What is the error in the measurement of the focal length? This was one of the brilliant question, and trust me, if this question comes, this will definitely make everyone lose their marks, because none of your standard formulas will work. Because usually when you find relative errors, you know that the power has to be multiplied with the relative error. But this is not in the multiplication form when you write 1 by f is 1 by u plus 1 by v. It is not in multiplication, it is in reciprocal with addition. So the only way to do this is by derivatives. No other option, guys. Just write this as f raised to minus 1 is u raised to minus 1 plus v raised to minus 1. Now take derivatives on both sides. So with respect to anything, df1 by dx, let's say, is d u raised to minus 1 by dx plus derivative of v raised to minus 1 by dx. Obviously, you cannot take derivatives directly. So what you will do, use the chain rule. So use the chain rule. So this will be df raised to minus 1 by df into df by dx is equal to du raised to minus 1 by du into du by dx plus dv raised to minus 1 by dv into dv by dx. Okay. So what will happen now? This guy's derivative will be minus 1 into f raised to minus 2. This df will be there. From everywhere, can you see dx, dx and dx will cancel out, is equal to minus 1 again u raised to minus 2 into du plus minus 1 again v raised to minus 2 into dv. Minus 1 cancels. So f raised to minus 2 df is there, is equal to u raised to minus 2 du is there plus v raised to minus 2 dv is there. So df is like delta f raised to minus 2 is like f square, this is delta u, this is like u square, and this is like delta v, and this is like v square. Take f square on the other side. Yes, take f square on the other side. So delta f will be f square delta u by u square plus delta v by v square. So that is the option, which is C option. Is that okay? Beautiful question, isn't it? Many students do not know. Actually, we can take this derivative and solve this question. And you have to also use chain rule over here. So this particular part, I have used the chain rule of derivatives. Cool. Shall we go ahead? Loved the question. I hope you're smashing the like button. If you've forgotten it, I'm reminding you. I know you guys might be hungry right now. Even I am hungry. But guys, I'm forgetting my hunger because I'm solving the questions. So, I mean, I have cleared my JEE. It's almost like 20 years back now. So, if I am so interested, if I am so motivated, so that you, whom I have not even seen, I am teaching you. You should be in front of the screen, solving all the questions with me as much as possible, understanding the concepts. Because this is the most power packed, efficient session for your April attempt. All the topics one by one. Okay. Now, why are we using mirror formula? Ayo. In an experiment, oh, lens is there. Okay, you put minus sign. Fine. Okay. So what will happen? This will be minus, right? This will be minus. Okay, this will be minus. So what will happen? Everywhere you will get a minus sign. But remember one thing. Remember one thing. The moment you convert it into errors, this is also minus. The moment you convert into errors, this will become plus because you want to find the maximum possible error. So whenever you convert into errors, this guy's contribution and this guy's contribution will become plus. This is most important step actually. This becomes plus because you are trying to find the max contribution of the errors. Maybe du is positive, dv is negative. If dv is negative, negative will become plus. Maybe du is negative, dv is positive. So this is negative minus positive means minus minus is like again plus only. So you will try to find the maximum possible contribution when you take the errors. So that is why I'll add both the terms for the maximum possible effect of error. Is that okay? Even if there is a minus sign, still the answer will be same. Yeah. Cool. Got it? Yep. Let's move to the next question on your screen. U and V are the object image distance, lens focal f. The correct graph is, obviously it won't be a straight line. It has to be one of the curves. Now, which of these curves is the question? So I'll tell you the equation comes very simple. It will not be like this. Either it is B or D only. See, we have 1 by V minus 1 by U is equal to 1 by F. Take cross multiplication. U minus V by VU is equal to 1 by F. So FU minus FV is equal to VU. Take it over here. Okay. So FU minus FV minus VU is equal to 0. I have an idea. Add f square on both sides. So f square plus fu minus fv minus vu. I will put f square over here. Both sides I have just put up f square. So guess what happens next? Guess what happens next? What is the next step now over here? I think this is an expansion of something. This is an expansion of something. Yep, you can take f common. you have u minus v over here, or f and v over here. Okay, we can do this. F square is there, right? So I'll write f into f, and here I will take fv over here. So minus fv, and then fu is there over here, and then there is minus vu. This is equal to f square. So how about taking f common? This will be f minus v, and then over here u common, and then this will be nothing but f minus v again. This is f square. So f minus v is common from both sides. So f minus v into f plus u is equal to f square. F minus v into f plus u is equal to f square. If you want, you can just multiply by minus sign. So this will become v minus f, and this will just become u plus f is equal to negative f square, because I have taken that negative sign outside. Okay. Now, believe me, this is nothing but a hyperbola, because x into y is a constant, whether positive or negative. This is a hyperbola. But imagine the variables are added or subtracted with something that is just a shift of origin. What is this? This is nothing but a shift of your origin. That's it. So your origin has been shifted. So instead of u over here, the origin has been shifted. So it has to be a hyperbola like this. Is that clear? Absolutely. Yep. Option D is the correct answer. Option D is the correct answer. Yeah. So the graph of image and object distances are hyperbolas. How many of you know this? How many of you knew this from before? If you knew this from before, great. Else, stuck. Okay, moving on to the next question, guys. Combination of lenses, and then we'll do those mixed silvering of the lenses questions also, and then directly to the prisms. Not much is left. I want your full focus. I'm also fully hungry. Yeah, I woke up at 6 o'clock in the morning. I had early breakfast. I didn't have anything. Yeah, I slept also very late, but we are always working. I have crash course classes. Everything is there. Everybody is working really hard for you. So full focus, guys. When you have thin lenses in contact, touching each other, they behave like one single lens given by the effective power P1 plus P2 plus P3. You just add their powers. Whereas their focal lengths, reciprocals will add, obviously, because P is 1 by F. So that is the effective focal length or effective power formula. You add the powers or you add the reciprocals. That's what you need to keep in mind. But when you have silvering of lenses questions, where maybe there is a lens over here and one side is silvered, okay, then such a diagram can be split into the ray enters the lens. Think about it. If any ray is there, that ray enters the lens, refracts, reflects, and refracts. So there are three events which happens: refraction, then reflection from that mirror, and then again refraction. But because of this entire events, refract, reflect, refract, it is eventually coming back. So the net behavior feels as if it is just coming back, means like a reflection, means like a mirror. So there is refraction, then there is reflection, and again there is refraction. So essentially, this is going to behave like a new mirror, which is your effective mirror. This is your effective mirror, because it feels as if the same ray would have entered over here, if the same ray would have entered here, it would have gone back just like that, the same way, with this effective mirror. So that is the behavior. So this is also combination again, but this is a combination of lens, mirror, and a lens to give you an effective mirror. To give you an effective mirror. The lens is coming two times, so 2PL plus PM is equal to PM. That's it. If you remember this much, rest of the things you will be able to do on the spot. So whenever you have silvering of lenses, just keep this in mind. Two lenses and a mirror becomes an effective mirror. Rest of the things you will be able to do on the spot. Like for example, the power of a lens formula is 1 by f. The power of a mirror formula is negative 1 by f. Okay, effective mirror is 1 by f again, but this is effective. So substituting this, you will be able to solve it. We will solve questions that will be better then. We'll solve questions so that it will be better. Okay, here is the first question coming up on your screen. The diagram shows two lenses L1, L2, 10 and 15 centimeters. Distance between them is how much? Okay, this is very straightforward. Come on, guys. This you can do directly. The ray eventually becomes parallel. That means this should be the focal point of the lens 1. So this is 10 centimeters. A ray passing through the focus of the other lens becomes parallel. So this should be 15 centimeters. So naturally, the total distance should be 25 centimeters. Just check it out. So option A is the correct answer. How many of you are giving option A? Come on, guys. Sir, do we also do class 11th thermo? I will tell you, guys. I'll tell you. Yeah. Yeah. Okay. Okay. Great. Guys, focus on the yeah, lecture, not on the things. Where are you from? Where am I from? Guys, come on. All right. Next question on your screen. The effective power of combination of 5 identical convex lenses is 25 diopters. Focal length of each lenses. So 5 lenses are there. So 5 into power of each lens is going to be your effective power. Power is always add in combination. That is 25. So power of each lens will be 5 diopters. Power is 1 by focal length. So it will be 5. So focal length will, but this is, yeah, this will be 1 by 5 meters. But we want it in centimeters. So focal length will be 100 by 5 centimeters, which is 20 centimeters. So 20 centimeters is option B. That is the correct answer. That's how you can solve it. Correct? Everybody with me? Okay, okay, okay. Great, great, great. Let's go to the next question on your screen. The position of the image formed by these three lenses combined together. Very nice question. Very nice question. Can you think how will it be solved? Focal length is 10 centimeter. This is 30 centimeter. I think the image of the first lens will be the object for the next guy. The object for the next will be image for the next. Again, you just need to repeat that process. Just apply lens formula and see what happens. So if you take the lens number one, here it is. 1 by V minus 1 by U is equal to 1 by F. Image, I don't know. Object minus 30. Focal length 10. Okay. So 1 by V is equal to minus minus is positive, goes on the other side again as negative. So LCM is 30. So this will be 3 minus 1. This will be 2 by 30, which is 1 by 15. So that is 1 by V. So V will be 15 centimeters. So image is formed at 15 centimeters. So the ray will finally try to meet somewhere over here. So I'm just drawing over here. So this distance is 15 centimeters where the image is formed. Now this is very interesting. If this is 15 centimeters, this is 5. Obviously, this much distance will be 10 centimeters. This much distance will be 10 centimeters, which is also the focal length of the second lens, which is also the focal length of the second lens. Oh, that means this is the focal point of the second lens. So actually the ray will become parallel. The ray will become parallel to the principal axis and the ray will go like this. Okay. So if it goes parallel, what will happen in the third lens? After it reaches the third lens, it will again pass through the focal point of the third lens. The focal point of the third lens is 30 centimeters. So it will be 30 centimeters where the image will be finally formed. 30 centimeters to the right of the third lens, which is B option. Which is B option. Very simple. Okay, great. Okay, 30 centimeters. So before going there, I will go back to the previous left questions. Remember, I told you we'll just do it. Mm, where did it go? This questions. Silvering of questions. Silvering questions. Guys, let's try to do these questions. A thin plano convex lens made of glass, 1.5 refractive index, liquid 1.2, plane side is silver coated. For complete reflection, lens is immersed in the liquid, behaves like a concave mirror of focal length 0.2, the radius of curvature of the curved surface of the lens. Beautiful question. Guys, read, yes, the star question, correct, correct. So read the question again. The entire setup is immersed inside. Yes, the entire setup is basically immersed inside. You have to be very, very careful. Okay. So first of all, my dear students, let me think of the diagram. The thin plano convex lens. The plane side is silver coated. This is plano convex. The plane surface is silver coated. So this is going to behave like a mirror. What is the job of a mirror? Whatever is there in the front, it will reflect it behind. So why not think as if the mirror, what it has done is it has created the image of the lens itself behind it. You just try to open it up. So it behaves like a biconvex lens. So this plano convex lens, because of the reflection inside the mirror, you will see the remaining part of the lens. This is now a biconvex lens, meaning both the surfaces are equal radius, both are convex, biconvex lens. Oh, perfect. And now what is given to me is the refractive index of the lens is 1.5. There is some medium which is there outside. Okay, there is some medium which is there outside, and that medium has a refractive index of 1.2. 1.2. The lens behaves like a concave mirror of focal length 0.2, meaning the focal length of this particular lens is nothing but 0.2 meters, meaning had you passed the rays parallelly like this, these rays meet somewhere over here, and this focal length is 0.2 meters. Can you find the radius of curvature? Have I not simplified the problem by a big deal? How many of you realize this? Hi, Dr. Sindhu. Yep. Pranad, I think more 40 minutes or so. Yeah, by 2 o'clock, I think we should be done. Did you understand? First, whatever lens was there, I replicated it behind, so I forgot the silver coating. So now it looks like a convex lens. It is placed in some liquid. Okay. Now, the focal length of the effective thing, whatever is there, the rays eventually meet 0.2 meters away. That is what I have done. Okay. So now, just use the lens maker formula. 1 by, that's it. So 1 by F is equal to relative refractive index minus 1, 1 by R minus 1 by minus R. Okay, minus R because one will be positive and one will be negative. That's it. That's the reason why I have done that. Okay, so this focal length is nothing but 0.2 meter. Refractive index of the lens is 1.5, of the medium is 1.2 minus 1. This will be 2 times of R, of course. So this is 0.2, 2 by 10, which is 1 by 5, or just 5, I can say. This will be 15 by 12. 15 goes with 3 5 times, 12 goes with 3 4 times, so minus 1 multiplied by 2 by R. Okay, so next step, guys, 5 is equal to 5 minus 4 is 1, so 1 by 4 multiplied by 2 by R. So 2 goes with 4 2 times, so 1 by 2R. So therefore R is equal to 10. Just check it out. R will be equal to 10. Yes, R should be equal to 10 unless we have missed any decimal place somewhere. The lens immersion in liquid, focal length 0.2 meters, the radius of curvature of the surface. Is it 0.10? For some reason, we have missed any decimal place. Just check it out. Mm, ah, guys, we have. What did we just do? So actually speaking, this would have been 10 is equal to 1 by r. So obviously r is 1 by 10, my bad. So therefore r is nothing but 0.1 meter. Yeah, so r is basically 0.1 meter, which is B option, which is correct. Perfect. Yeah, we had to take 1 by r. Yeah, no, everything was in meters. Everything was in meters. Everything I've kept in meters. Focal length was in meters. I have kept it in meters only. So I've not changed the units anywhere. Yeah, so everything is fine. Cool. Let's go to the next question, guys. Yep. Let's go to the next question. So this was one question, and this another question, star mark question, which I wanted to discuss with all of you. This one, observe this. If there is a thin convex lens, each having R, one side is polished, what distance will the object be placed so that the image is formed on the object itself? Very good question. Observe this, because combination of lens, silvering of lens was a common question in many of the January shifts. So if I take this particular lens and I silver it, this is like two lenses, two lenses a mirror, and a mirror, which then behaves like a new mirror as such. So 2 times the power of the lens plus the power of the mirror is the effective power of that mirror. Effective power, this is the net combination. This was the original, which have split it up into two lenses and a mirror. Effectively, it behaves like a mirror. Okay. So what is the power of a lens? The power of a lens is 1 by f, so 1 by fl, plus power of a mirror is 1 by fm, is 1 by what is it? This is nothing but f effective of that mirror. But mirror, always there is a negative sign, so keep that in mind. So if you want, you can take the minus sign here, and this will be 1 by fm minus 2 by fl is equal to 1 by fe. Just take the minus sign, minus minus is plus, this will become minus. Okay, now let's think. For that effective combination, right? Whatever is that effective mirror, whatever is that effective mirror, it is given that the object is placed such that the image is formed on itself. So if the object and the image coincide, that means the ray retraces the path. That means this distance should be the radius of curvature. This distance should be the radius of curvature. So the object distance is the radius of curvature, which is 2 times the power of the effective lens. 2 times the power of the effective lens, magnitude wise. So you just have to put whatever is the effective power from here. That is what the solution should be. So what is that effective power? To solve that, let's go on the next slide maybe. Yeah. So we have 1 by fm, we had 1 by fm minus 2 by fl is equal to 1 by fe. Yes, 1 by fe over here. Okay, what is the focal length of that mirror? If you if you take if you take a mirror, if you take a mirror, I know that the radius of curvature of this mirror will be 2 times of fm. So fm is r by 2. So fm is nothing but r by 2. So I can just put over here, this is nothing but r by 2 minus 2 into 1 by fl. What is the focal length of this lens? Use lens maker formula. Use lens maker formula, which is mu minus 1 by r minus 1 by minus r is equal to 1 by fe. Okay, so 2 goes on the top. So 2 divided by r minus 2 into mu minus 1. This becomes plus. So 2 by r is equal to 1 by fe. Now, as you can see, 2 by r is obviously common over here. So I can write this as 1 plus. This will be 2 into mu minus 2, of course, is equal to 1 by fe. 2 by r is common. 2 into mu and 2 into 1. I've just taken it. So actually this should have been minus if I'm not wrong. One second. So we 1 minus 2 mu minus minus will become plus, so plus 2. So this will become 2 by r, and in the brackets I have 2 over here. Yeah, correct. So this should become 3. Yes. So 3 minus 2 mu over here is equal to 1 by Fe. So therefore, the focal length effectively, just reciprocal of that. So R into 3 minus 2 mu whole thing divided by 2. R into 3 minus 2 mu divided by 2. So when I find the focal length, just substitute it over here. So just substitute this value r into 3 minus 2 mu, r into 3 minus 2 mu, whole thing divided by 2. So therefore, I will get the object distance as 2 cancels, r into 3 minus 2 mu divided by goes off. R into, yes, yes, that is what I will get. Everybody with me? Absolutely clear, guys? Okay, perfect. I think that slash should not have been there. Yeah, but this is what it would be. So these were those questions which we had to discuss. Now let's go directly to prism. Yeah, power of a lens is also done. Combination of lenses also done. Okay, let's go to prism. Oh, but before prism, this biconvex thing is there. These questions also came many times where a lens is broken down into 2 or 3 parts, and then you had to find out what is the power of each of this thing. Okay, yeah. It will come to the denominator. Which one? The previous one? Did we just miss taking a reciprocal somewhere? Where did it go? Okay, sorry guys, I think I missed that part. Once again, I think I did not take it to the reciprocal. Sorry, sorry, sorry. Let me just do it here. So when I take Fe, that will be R divided by 2 multiplied by 3 minus 2 mu. This value, I will put it back over here. This value, I'll put it back over here. Yes, where did it go? This value, R by 2 into 3 minus 2 mu. R by 2 into 3 minus 2 mu. Okay, and this 2 obviously was there as it is. 2 will cancel. So this will be R by 3 minus 2 mu. This will be the magnitude of the object distance, but when you take it with the sign, it will be negative. So it will become 2u minus 3. This is just the magnitude. So u will be obviously minus of R by 3 minus 2 mu. So it will be R by 2 mu minus 3. Is that okay? This would be the correct answer then. Okay, cool. Let's go to the next question, guys. Next question, the biconvex related questions. Biconvex related questions. Okay. So when you break a lens, how to solve those problems? When you have a lens like this, and you take this part of the lens and this part separately, if this had f, this will also have f, this will also have, there will be no change over there. But when you take a lens like this and break it into two plano-convex lenses, if the power was p, power will become half. Power is inversely related to the focal length, so the focal length will become double. So when you break it like this, no change. But when you cut it like this, obviously the powers will get divided. So focal length will double. Here there is no change because it doesn't matter, guys. I mean, if you take the rays coming from the top and the rays coming from below, they would be meeting here. Still, the rays will meet over here only. There will be no difference at all. There is no difference. Yes, the intensity of the light will reduce. Intensity will become half. Half of the light will go only. So intensity will reduce, the brightness will reduce, but focal length will not change. So such questions were asked. Look at this. So biconvex lens has some focal length. When it is immersed in a liquid, what will be the focal length? So when it was in air, the focal length in air was refractive index of the lens minus 1, 1 by r minus 1 by minus r. Okay. And this focal length, how much was it? 20 centimeters. Refractive index of the lens was 1.5. This will just become 2 by r. But the moment you immerse it in a liquid, I don't know what the focal length is. The difference will be, this will now be 1.5 divided by refractive index of the liquid, and still that 1 by r minus 1 by minus r will still be there. And I just want to find this much part out. So this will be 15 by 16 minus 1 and into 2 by r again. And I want to find the focal length of the lens. Somehow I can find 2 by r, or I can just divide both of them. Yeah, just end up dividing both of them. It will be very, very easy. So 1 by 20 by 1 by focal length will be 1.5 minus 1 divided by 15 by 16 minus 1. 2 by r will cancel out. So 2 by r and 2 by r will just cancel out. So FL will go on the top, 20 will be over here. This will be 0.5, of course. 15 minus 16. Yeah, 15 minus 16, that is minus 1 by 16. This has just cancelled out. So 0.5, guys, is nothing but half. So 2 will be there over here and 16 will be there on the top. So this will be minus 8, I believe. So that will be focal length by 20. So therefore, focal length will be 8 into 2, 16. So minus 160 centimeters. Minus 160 centimeters, which is D option. Yep, it is D option. Very good. Very good. Excellent, guys. Some of you got it. Proud of all of you. Okay. Next question on your screen. A symmetric thin biconvex lens is cut into 4 equal parts. The along two planes AB and CD, the power of the original lens is 4D. Then the power of each part divided will be how much? Guys, straightforward. See, if you take this lens, it has a power of how many diopters? 4 diopters is that power. That is that power. When you break it into two such parts like this, each power will be 2D and 2D. It will become half because 2D plus 2D should give you 4D. Now, when you cut it further and take this part, this part, this part, and this part, how will the power change? It will not change. It will still remain 2D, 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 and 2D. There will be no change when you cut it along this line. Yeah, the focal length power, nothing will change. So each one of them will have a power of 2D, which is option A. Many people thought 4 parts, so divide by 4, and they gave the answer as D. No, no, no. See how you have divided it. Yeah, the answer will be just D. Correct. Very good. All right. Okay. Prism, ready for it, guys? The last part, I think it will hardly take 15-20 minutes now. Show some fire in the chat box, guys. Come on, even I am tired. Yeah. Show some fire in the chat box. Show some enthu. If you have forgotten to subscribe, please subscribe. If you have forgotten to like, please like. Okay. Lot of sessions are scheduled for all of you on the Vedantu JEE English channel. Let me remind you guys, many people do not know this. Our channel is fully active, crazy, guys. I mean, now we have reoptics, then you have matrices, tomorrow modern, complex, even chemistry is there. It will just come up in a bit. Okay. And yesterday, Namrata ma'am conducted a orientation session for your crash batch, where even today I am taking a class, right? So if you have forgotten to join the crash course, please be a part of it. All the details have been mentioned here. The link is also there of the crash course in today's current video, which you are watching. Yes, it is there. If you are watching this current video, it is there right over here. The JEE 2025 crash course. It's a very affordable batch. I mean, just look at it, guys. 999 rupees with JEE Mains and advanced preparation. Crash combo, you get KCT, VIT, Triple E also. And if you want the PYQ book, you go for the Crash Pro. I mean, these rates are like a steal, considering you are getting live classes, in-class doubt solving, practice papers, class tests, mock tests, full syllabus tests with all India ranking. Yes, all India test series online, handwritten notes, pedagogy app with 500 plus books, VBuddy with recorded classes also, Telegram group. I mean, really, guys. I mean, you should, you should, you should feel ashamed that this batch is for 999 rupees. Okay, so make the best out of it. Yep, for all of you, this is going to be really great. Obviously, many students will be going for the crash combo because you will be giving VIT Triple E and KCT, either one of them, 100% as a backup option. Thank you, Sukruti, Indra. Finally, Jarvis, Maha, Warrior. Thank you. Finally, that fire is coming. Okay, so if you take a prism, the formulas are, first of all, Snell's law is always applicable at every surface, needless to say that. So sin I by sin R is sine emergent angle by this angle, which is refractive index. The total deviation is incident angle plus emergent angle minus the angle of prism. Angle of prism is that angle which is the angle between the two surfaces which refract. So this angle is the angle of prism. Incident angle is what the incident ray makes. Emergent angle is what that final ray which comes out makes with the normal. That is your emergent angle. Okay. But also remember that, what do you say? The deviation versus the angle of incidence goes something like this. That formula which was there for deviation, which I just blocked over here. Okay, that deviation changes like this, and there is minimum deviation. There is minimum deviation when the incident angle is emergent angle, and when that happens, you will see the refractive index is sine of a plus delta minimum by 2, whole thing divided by, this is inside the brackets, divided by sine of a by 2. Keep this in mind. Okay, so this is a special formula when deviation is minimum. When your prism is thin, for thin prism, what happens is more or less all the deviations are roughly equal to the minimum deviation, and using small angle approximations formula, you get it as a into mu minus 1. This is very, very important. Also, if you take a prism like this with some angle over here, and you pass in some white light, which is a mixture of all the rainbow colors, the violet color will deviate the most. Indigo, blue, green, yellow, orange, and this is your red. This is how the spectrum will look like. This is called as dispersion. This is called as your dispersion. Yeah. This angle which is there, that is called as angular dispersion. Angular dispersion, delta theta, which is also nothing but how much did violet light deviate minus how much did red light deviate. If you are wondering what these are, delta R will be angle of prism is same, refractive index of red minus 1, and this will be nothing but angle of prism is still the same, violet refractive index minus 1. Yep. Please keep in mind, it's always the violet which has the highest refractive index as compared to the average color, which is yellow. Then comes the last one, which is red. So even the deviations are in that same order. Deviation of the red is the least. Yellow color, which is the average color, has okay deviation. And the violet color has the maximum deviation. Not just that, this being the mean color, yellow, mean is always yellow color. The refractive index of the yellow color is actually the average of the two extreme colors, meaning the violet color and the red color. So this is actually the average. So this is something which you should again be aware of. Okay, clear? Great, great. I hope this is absolutely clear. Great. So I wrote stretch string instead of open pipe. How many marks? Yeah, Wiki Gaming, just hope that the teacher who is going to correct it doesn't see it so much. Then you might not lose marks. But if they see, maybe half a mark to 1 mark, maximum half mark to 1 mark. Okay. Okay. Great. Cool. Let's solve some questions based out of this. Refractive index of the material of a glass prism is root 3. Angle of minimum deviation is equal to the angle of prism. What is the angle of the prism? Guys, read the question carefully. The refractive index is given. Minimum deviation is equal to the angle of prism, means delta minimum is A. What is the angle of the prism? Okay. Is there a formula related to delta minimum A and refractive index? Yes, there is. Mu is equal to sine A plus delta minimum by 2, whole thing divided by sine A by 2. That's the formula. Refractive index is root 3. Angle of prism is the same as delta minimum. So A plus A, I can just replace it, divided by sine of A by 2. Okay. Well, let's see what do we get. So take it on the other side. So root 3 into sine of A by 2 is equal to A plus A, 2A, 2 cancels. So this will be nothing but sine of A. How do I solve this? Use little bit of your mathematical knowledge. Yep. I can write this as sine of 2 times of A by 2. Yeah, this is as good as saying this is sine of 2 times of A by 2. A by 2 plus A by 2. So use 2 sine theta cos theta. So 2 sine A by 2 into cos A by 2. Double angle formula. Sine A by 2 will cancel. So root 3 will be 2 times of cos of A by 2. So therefore, cos of A by 2 is root 3 by 2. Therefore, what does it tell you? Whose cos is root 3 by 2? 30 degrees. So this is 30 degrees. So therefore, A will be 2 into 30 degrees. So it will be 60 degrees. So angle of the prism is 60 degrees, which is option A. Perfect. So this kind of question was asked. Can you believe it? Yeah. Yes, many of you spammed the answer as A. Perfect, guys. Kudos. Refractive index of the prism of angle A is cot A by 2, the angle of minimum deviation. Again, they have asked the question on the same formula, means it is very important. So again use mu is equal to sine A plus delta minimum by 2, whole thing divided by sine A by 2. Okay. The refractive index is cot A by 2. Apex angle means angle of prism. Don't get confused. So this mu is given to be cot of A by 2. This entire thing. Cot is nothing but cos by sine. Cot is nothing but cos by sine. So I'll put it as cos of A by 2 by sine of A by 2. Sine of A by 2. But what do I do over here? The minimum deviation is asked. Okay. So nothing I can do much as of now. So this is sine of A plus delta minimum by 2. This was sine of A by 2. Okay. So as you can see, this and this will just get cancelled off. This will just get cancelled off. So I'm getting cos is equal to sine. If cos is equal to sine, that means they are complementary angles, or basically I can say sine of yeah, sine of, I can just say 90 minus theta, which is A by 2, is equal to sine of A plus delta minimum by 2. So instead of cos, I converted it into sine 90 minus theta, because sine means I can compare the angle. So whatever is there inside is comparable. So pi by 2 minus A by 2 is equal to A plus delta minimum by 2. 2 cancels. Therefore, pi minus A is equal to A plus delta minimum. Therefore, what is asked? Delta minimum is asked. Therefore, delta minimum is pi. Take A on the other side. So minus 2A. Pi is like 180 degrees. So if you convert it into degrees, 180 minus 2A, which is C for Captain Shreyas. Yes, very good. Many of you got it. Yeah, very good, very good, very good. Awesome. Now, I can see the same question was also asked, but instead of degrees, they have asked it in radians. So can you believe? Same question, instead of degrees, they have put it in radians. In the same attempt, they have asked it. Obviously, the answer for that will be again pi minus 2a only. So that answer will be A. So 2 times this got repeated in January attempt. Okay. Next question. There are two prisms, P1 and P2. P1 has 4 degrees refractive index. P2 has some another refractive index, another angle. But there is dispersion and there is no deviation. That is very interesting. Let's try to visualize what exactly is happening. Then we can easily frame the equations. So there are two prisms. There is dispersion but no deviation, meaning somewhat like this. So if our light comes like that, it gets deviated. It will go like this. That will be how yellow color will go. There is no deviation, meaning if you draw the incident light, it is parallel to it. Actually, right now it doesn't look parallel, so let me make it look parallel. So it goes parallel like this, no deviation at all. So net deviation is 0. But if there are other colors in it, which will be there, white obviously is made of many colors. So it will look probably like this. The red color will probably go here like this, maybe like that. So as you can see, there is clear cut dispersion which is happening. Dispersion is there. There is dispersion, but what is not there is no deviation. Deviation is not there. That means if the ray gets tilted by some degrees, in the next prism, it is again tilted by the same degree so that it becomes parallel. Did you understand the logic? How much ever deviation occurs in the first prism, same deviation occurs in the second prism. If it turns here, it will turn back so that it will become parallel. That is the idea behind this. Oh, okay, fine, sir. So what is the formula for deviation? Angle into refractive index minus 1. Angle into refractive index minus 1. Isn't it, guys? Everybody? Very good. So what is the angle of the first prism? It is given to be 4 degrees. Refractive index 1.54 minus 1. Okay. Second prism, that is what we have to find. And the refractive index 1.72. Okay. So from this 4 degrees multiplied by, what will this be? This will be 0.54. This is A2. This will be 0.72. Therefore, A2 will be 4 multiplied by 54 divided by 72. It's divisible by 18. 3 times, 4 times, 4 cancels. So it will be obviously 3 degrees. 3 is C for your captain, Shreyas. Perfect. That's correct. Option C. Understood? If the question was deviation is not there, but sorry, deviation is there and dispersion is not there, then what will you do, guys? Put it up in the chat box. Let's say no dispersion but deviation. If that thing happens, example, if that thing happens, then what will you do? Yeah, whatever spread is there in the first case, the dispersion which is there in the first prism will be the dispersion in the second prism. So whatever it's spread by, it is again countered and it is converging. So there is no spreading which is happening in the net combination of the prism. So delta theta will be equated if there was no dispersion, if there was net, no net dispersion, delta theta. And remember, delta theta is nothing but deviation of your violet color minus the deviation of your red color. Yeah, that is the formula. Correct. Very good. Awesome. 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 And there we come to the end of the class. What a powerful, power packed, punchy class this was. Concepts and questions with PYQs done and dusted. I think after this, your reoptics confidence level should be at the next stage. Please practice some more questions today. Let's do all the high weightage chapters, and day by day pick up those high weightage chapters, master it, so that every question you should be able to do in the next 10 days, and after that we'll go to the full syllabus mock test. Ready for it, guys? So if you master these 10 chapters, or whatever those 10-15 chapters which will be there, that's it, guys. I mean, nothing more is required. You will be already at 200 marks, 180 marks easily. So let's work for it. And I want your full attendance till the last session. Okay? Promise me that. And let me know in the comments, how the session was. Yeah, where you are from, whatever you wanted to ask. Just let me know. Thank you for liking. Thank you for subscribing. This was Captain Shreyas signing off. Bye bye.